Hi everyone, welcome back to Java 1 for All. In this video we are going to talk about the collection called CopyOnWriteArrayList. Let's create a new class here called CopyOnWrite test 01 and PSVM. So we basically saw already how to create kind of thread safe collections in previous videos using the collections.synchronized list. But here the CopyOnWrite is a little bit different because it works with the concept of immutable technically objects, but I'm going to explain why technically. Immutable objects is a object that you can never change once it is created. So there are a few techniques. For example, first you need to make a class final. So if you create a class called anime and you want to make this class immutable, you need two things. First, the class should be final, and then you cannot do something like this. You cannot create a way for threads to change the attributes inside this class once it is this object is created. And why is that? Because if we have multiple threads trying to change the name, well, they will interfere with other threads. So the immutable object, all the attributes, you could have 10, all of them should be final. And then you have only one way to create the data of this object is through the constructor. And then you provide a read access, and here you have immutable object. So why is this immutable? Because if I want to change the name, I need to create a whole new anime object. If I have like 10 threads and 10 threads are trying to create or change the name, each one of them will have their own version of that object, so they are not interfering with each other. And the CopyOnWriteArrayList is basically doing something very similar. So for example, if you create here a list of integers, CopyOnWriteArrayList, what happens when you create a CopyOnWriteArrayList is that every change you do, you are going to create a new list. So this is just one object. So if I add one number, I will have 1. Then if I try to add another one, I will have another entirely new list with 2 numbers. If I try to add another one, another entirely new list with the last number. And the same, if I want to remove, it's going to copy the entire array, and then we are going to have another brand new list with the current data. So basically, every time you are adding or removing, you are changing the entire structure. You are copying the entire array and creating a new one. So when you do this, the advantage is that you are kind of safe. If you have one thread going over that specific memory address, that's not going to change. But you have to be careful because it's not entirely thread safe. Now we are working with integers, but for example, imagine that we have a object that's anime. If this is not, let's say, thread immutable, you can have multiple threads changing the value from this specific list. So if you add and remove, that's okay. But if you have anime that's not immutable, you can have multiple threads messing up with this object inside this list, and that's not going to change the memory address or create a new list. Okay, so let's see some examples. Let's imagine, for example, that we have 2 runnables. One that's going to add, not just going to print, another one that's going to remove. So let's initialize this with some 2000 values. So I'm adding here this I 2000, and then let's create the first runnable. The first runnable will be called runnable iterator. Why am I using the iterator? Because iterator works in a very interesting way. It makes a copy of the state of that list at the time we are creating. So I can call here, let me call this list.iterator. And then I'm going to do the following. I will call the sleep in a different way, times time unit dot seconds dot sleep. It's the same thing as the thread sleep. And then try catch, and here I'm going to do the following. I just want to print out the data from that iterator. We know how to do it with while, but we can use lambda or method reference now that we know how to work with. Cool. So we have one thread that's going to print all the data inside this CopyOnWriteArrayList, and now I'm going to do the following. I will copy this, and I'm going to call it runnable remover. And then I will just remove, let's call printf %s thread name removed %d, and then let's jump one line. So here thread current thread get name, and then comma I. So I want to start 2 threads with this runnable iterator. So new thread runnable iterator dot start, but they are going to sleep for 2 seconds, and then the runnable remover will probably get ahead and start removing 500 values from this CopyOnWriteArrayList. So basically they are going to start, they're going to sleep right here, and then by the time they reach this, they will already have 2000 inside because the main thread is running top down. And then before they reach line 18, this one is going to remove 500. So let's see the result. Ctrl+Shift+F10. As you can see, we have 500 removed, and then we have 2000. But look at what is interesting here is that we still have the values before removing the 500. So that's the CopyOnWriteArrayList with the iterator. Just one thing, you cannot remove while iterating. I think the iterator here does not have a remove. So if you try to remove, I think it will give a nice exception. Yeah, so you cannot remove or adding when you are iterating over it. Cool, so that's everything I wanted to tell you. I think that's enough for today. Let's continue with more videos in the next, more content in the next videos. It's 9 p.m., quite tired already. See you guys, bye-bye.